Okay, dokie. What we're going to do is we're going to talk about the notes for lesson 3.2c. And in 3.2c, we talked about the standard deviation of residuals. Standard deviation of residuals. Now, what is a standard deviation of residuals? Well, it's just like very similar to the standard deviation that we normally find. Is we need to do the sum, okay? The sum of our residuals, in this case, residuals squared. And then we're going to divide by n minus 2. N being the total number of columns we would have, all right? Total columns, all right, or data points that we have for one variable, okay? And then after that, we have to take the square root of that, and that's how we find our S value. Well, how do we interpret that? Well, the actual, whatever we have for our Y value, okay, for our response, is typically about S away from the predicted value of predicted by the LSRL. And that's what a standard deviation is. Now, instead of being a mean, our mean is essentially this, all right, least squares regression line. All right, there's our least squares regression line where we have a plus bx, and then we have a bunch of points on here, which are our actual value points, and we would have that. The S value is the average, all right, of how much it typically varies, all right, from the predicted values of LSRS. So that's why we take the actual values is typically about S away from the number of predicted values of LSRS. Now, things you need to remember that residuals are the difference between the actual and the predicted values. Also remember that SD, the standard deviation, is typically a variation, all right, of the response variable from the mean. And the mean in this case, as I said, is our least squares regression line. Now, other things we have to know is a coefficient of determination, which is our R squared value, if you went through a lesson on this and finding R squared, we know we can interpret this about whatever our R squared percent of the variability in the, all right, in this case, our Y value, okay, in our response variable. So I'm going to call response, you can. Response is accounted for by the least squares regression line. And so as this least squares regression line, as it changes, this percentage change because the area between those also changes. So about whatever percentage, the R squared percent of the variability is accounted for by the least squares regression line. Now, when you compare R and R squared, R is simply the square root of R squared. This is a coefficient, all right, okay, correlation coefficient, all right, coefficient, whereas, as we said right here, the R squared value tells us really the variability that Y is accounted for by the least squares regression line. All right, well, we're going to go through some examples on how to apply these things in just a little bit. So we'll look for the next video coming up.